Let's get started, guys. Let's get started. Just a quick second. All right. Hi, guys. Very good morning and welcome, guys. Welcome to today's class. So, before we get started, again, as we always do, let's go ahead. Let's do a quick recap. Let's do a quick recap. In the last class that we went ahead, that we worked on. Right. So in the last class, we started working on the concept of Docker, where we understood what is exactly Docker, how do we go ahead, how do we build the containers, how do we deploy our application on top of these containers, and what are Docker images, all the other concepts related to Docker. So in today's class, we are going to understand how do we go ahead, how do we start building our custom images with the help of Docker. Yeah. So let me just scroll down to the Docker page. All right. So in the last class, we have seen how do we go ahead, how do we run containers, attach volume for the containers, expose containers via via portings. How do we go ahead? How do we use the option called as host volume in order to go ahead, in order to deploy the code on top of the container? This is what we have seen in the last class. Okay. So in today's class, we are going to go ahead, we are going to take it forward to the next level where we are going to understand how are we going to convert our application, how are we going to go ahead, how are we going to build our application into a custom image. Okay, I want my own custom image, and this image has to be deployed on top of Docker. Okay, how are you going to build an application and deploy this application on top of Docker? So that is what we are going to check it out today. All right. So we have EC2 instances. Second, guys, I have a lot of different servers running here. I'll just stop them. And this is my Docker server. So in the last class, we were using this server. I will use the same server. I will go ahead. I'll use the same server. Select Docker Lab, instance state, start. All right. So this is my brand new server, guys. This is my brand new Docker server. Okay. Sorry. This is my existing Docker server. So let's connect to the server real quick. Downloads, enter SSH. Yes. All right. So this is our Docker server. In the last class, we installed Docker. There we go. So we have Docker. And if I say Docker PS, okay, again, we need to modify permissions. Sudo chmod 666 var run docker sock. Okay. You need to give permissions for this particular folder. And now if I say Docker PS, I don't have any containers. Docker PS -a, I can see there are some old containers that were running. Okay. So these are the containers that we executed. Okay. Food app, ecom app. And then what did we do? We took the code, guys. Okay. We took the code from GitHub. Once you took the code from GitHub, Docker PS-a. So let me delete this container. Docker remove -f. So here, so this is the code from the container. So once you have the code, sorry, once you have the code from your GitHub, Now, what are we going to do? We are going to take an existing Docker image, Docker Hub. Go to Hub. So here, what was the image? First, we took HTTPD image, HTTPD. On top of this HTTPD image, we went ahead, we have deployed our e-commerce application. Okay. So we went ahead, we deployed e-commerce application. So let's see how to do it today again. So we said Docker run -dt -name. I'll say EC app. Okay. And followed by -p port. On what port I want to expose this? So I want to expose this on 8080:80 and -v volume. So where is the code? Code is on home, Ubuntu, ecom. So the code is here. Followed by where is that I'm supposed to copy it on the HTTPD. So this is the path. User local Apache to htdocs. So you're supposed to go ahead, you're supposed to copy the code on this particular path, and I'm saying I want to use HTTPD image. Enter. So it is downloading the HTTPD version 2.4. No problem. Any version does not matter as long as I have the base image, Docker images. So you have HTTPD image 2.4. Okay, perfect. And now if I say Docker PS, I can see our application running. This application is running on port 80. So if I browse, if I go back to the server, if I copy the IP address, paste it, :8080, enter. I'm able to go ahead, I'm able to see the web service. I can see the website is running. So we deployed e-commerce application. Then what did we do? We took an Nginx image. Okay, on top of this Nginx, we deployed food application, Docker run -dt -name fd food app. Okay, -p 8090:80 -v. Where is the code? Home, Ubuntu, and what is that? Home, Ubuntu, followed by food app. Okay, and where is that I want to copy? So I'm using Nginx, no? So I'm going to use Nginx as a web server. Nginx. So again, Docker Hub. Nginx. What is Nginx? Nginx is also a web server. We have also seen how to use Nginx. Yes. Nginx now. With the help of Nginx, we'll deploy this application. So what is the document root directory of Nginx? You have user share Nginx HTML something, no? Here. Document root directory is user share Nginx HTML. Okay. Now, what is the base image? The image I'm using is Nginx. Enter. Same thing. We have a new container. We have a new container here, Nginx, and it's running on port 8090. Okay, 8090. So if I copy the IP address, okay, :8090. There you go. I'm able to go ahead. I'm able to see my application. So we deployed static applications, guys. This is static application. Okay, this is static application. Now the question is, see, these applications, again, see what is the process, how are we running? So if I want to run the application, I need the code. Okay, I need the code and I need a base image. Docker images, I need a base image. So these are the images. Now, without running them in form of a code and a base image, I directly want to run this as an image, guys. Okay. Now, whatever my application is there, no, e-com application, food application, I should directly convert this application in form of a code. So let's see how to do that. So before that, sorry, I should convert this application in form of image. So before that, I'll remove everything, guys. Docker rm-f. So all the containers are gone. Docker images. You have images, guys. So to delete images, you can say Docker Docker
RMI.
RMI. You can say RMI, remove image. You can give the image ID. Okay, you guys can do this, or you can say Docker image prune. Image prune. So when you say image prune, it will go ahead, it will delete all the unused images. Whatever images are not under use, no, it will delete it. Docker image prune -I. Okay, -A. Yes. You see what it's saying? This will remove all images without at least one container associated to them. So it is saying it will delete all the images if there are no containers. So now look at this. No containers.
Kiran, is it like prune means like, even once it is not used, then it will be deleted.
That's it.
Okay.
That's
If it
right.
is used at least once, then
No,
it
no, no,
won't
no, no.
delete anything.
Not once. Not like that. It should be
Okay.
not in use in current state.
Okay, okay, not in its current state.
Currently on that image, no container should be running.
Okay, got it.
Then it will delete.
Okay.
Got it? Okay, so what I'll do is, where is the notes? Hmm. Docker images. Docker image list. Docker RMI image ID to delete images. Okay, and then Docker image prune -A will delete all unused images. Got it? So Docker images. Okay. So now guys, now the idea is, I'm going ahead, I'm working on Docker, I'm going ahead, I'm building my containers, I'm doing a lot of things, but how am I doing, guys? See, whatever I want to do, I'm using an image. Whatever I want to do, I'm using an image. Now, rather than going ahead, rather than deploying your code, on top of another container, now what you need to do is, now we need to convert this code into an image. So this is where the concept called as a Docker file comes into the picture. Docker file. So what is a Docker file? Okay. A Docker file, pay attention guys, very important. A Docker file is a text file containing instructions for building a Docker image, specifying the base image, commands to run, files to copy, and environment variables all in a sequential manner. So what is a Docker file, guys? A Docker file is nothing but a script file. You guys can simply imagine this is like a script file. Now inside the script file, what will you do? Inside the script file, you will go ahead, you will write commands. What kind of commands? All different type of commands that will help you in order to go ahead, in order to build an image here. Docker file automates the process of creating container images, ensuring consistency and reproducibility. So what Docker file does is, it will help you in order to go ahead, in order to create container images, and in order to make sure that these images are running successfully. Okay. Now, whenever you want to go ahead, whenever you want to build a Docker file, guys, whenever you want to build a Docker file, okay, so there are some certain instructions, or there are some certain commands that you need to follow. Okay, so what are those instructions? What are those commands here? These are the commands. Okay, from, run, copy, work directory, environment, cmd. So these are different commands. Again, how are you going to use these different commands? We will go ahead, we will learn them. Okay, but now you guys should learn how to build your own custom Docker file, how to create your own Docker file with the help of this Docker file, we will be able to go ahead, we will be able to build a Docker image. So I'll just copy this, okay? And I'll put it here. Docker file. Very, very, very important. So this is your primary job as a DevOps engineers, guys. So once you get the code, you know how to build, you know how to deploy it manually. But now we don't want manual deployment. Now what you have to do is whenever you get any application code, you're supposed to first go ahead, you're supposed to first convert the code into machine readable code and then convert it into image. 1 second.
Kiran, is it like uh, doing automation to the
Absolutely.
image, like
Yes, yes, yes. Yes.
automating it?
Yes, you can say you're automating it.
Yeah.
Okay. What you're trying to do is you're trying to go ahead, you're trying to make your environment in a lightweight format. Got it, right? Now your application is your application is in a really your application is really heavy. Okay. Now from that heaviest layer, now what you are trying to do is I'm trying to go ahead, I'm trying to build my application into the most lightweight component. Okay. 1 second, guys. 1 second. Control Z. 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 Docker file. So what I'll do is I'll just okay, I'll just copy paste it till here. Okay. Docker file commands. Purpose, structure, instructions. Okay. Very, 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 very important. Okay. Now, what Docker file does, guys? Docker file will help you create a Docker image. Okay. That is something you know. So they are saying you're supposed to write a script file. It is a text file. Now, where are you supposed to write this text file? Is first, you will go to the code. So where is the code? This is the code, no? Ecom. So I'll say CD ecom. I'll say CD ecom. Go to the code. Now in the code, okay. So you have different files, guys. You have different files, no? Here, now you will create a Docker file. So 1 second, guys. Docker init. Docker init is not a Docker command.
Are we adding the additional file, or we are modifying the existing?
No, no, no. You have to create a new file. You have to create a new file. Actually, there is a new command that has been introduced. I'm just trying to read this. Why Docker init is not running? Usage Docker init options. So what are my options? Options enti? Options version. If I say Docker init, see the additional examples to give the option of each language of framework. Why Docker init? ఎందుకు రన్ అవ్వట్లేదు? Docker init -help. Let's see. Do I have it? Okay, we don't have the commands here. Build commands, run commands. Okay. Looks like this command is not yet activated. So, okay, I'll talk about this command later. Okay. So now guys, once you're in the code, once you're in the code, so here, first what you have to do is you have to create a file. Okay, so I'll say vi, and the name of the file should be Docker file. Got it? The name of the file should be what? Docker file. That is mandatory. Enter. Now, in this Docker file, what are you supposed to write it? In this Docker file, you are supposed to write some set of instructions, guys. Instructions like what is, first, to deploy our code, what image did we take, guys? What was the image that we took? We took HTTPD image, no? Yes. So I want to mention the same HTTPD image in this commands, okay? So I'll say hash, I'll say select HTTPD as a base image, That means I want to use this as a default image. Now, how to select it as a base image? So here you have some Docker commands. You see, structure instructions. Common instructions include from. Now I can use this from command, specifies the base image to start from. So if I want to specify what image to use, so here I'll say use from command to specify base image. Specify base image. So I'll say from what? What to guys? What is my base image? HTTPD, from HTTPD, and always make sure, guys, now whenever you're doing this, no, okay, try to select the latest version. So what is the latest version? Alpine is the latest version. So I'll say HTTPD Alpine. Okay. So this is to make sure that the image that you're building, no, it has to be in a lightweight environment. So to do that, you go ahead, you start your choice by selecting the latest image. Okay. HTTPD Alpine. Then after you take HTTPD code, what did we do? Yes, guys, what did we do? Here, we took the code, we deployed it on the document root directory. Yes or no? Look at this. We took the code, path on local, path on container. We took the code, deployed it on the document root directory. So I'll say now we have to copy the code. So copy the code to the image. Okay. How to copy? Use copy command to copy the code. Use copy command. So how to use? I'll say copy. What is that you want to copy, guys? The code. Where is the code? It is in the current directory. So I can say dot, or I can say star. Star represents everything. Yes. Now where is that I want to copy? What is the document root directory of HTTPD? What is the document root directory of HTTPD? Here. User local Apache to htdocs. I'll copy this. I'll paste it. Now pay attention, guys. I'm saying from HTTPD. So I'm saying I want to use HTTPD as a base image, And then on top of HTTPD, I'm simply saying copy what? Star. Star represents what? My code. Copy star my code to this folder. Okay, this document root directory. Now, once you have updated these comments, we'll just save this. Okay. Now look at the code, guys. So this is your
Kiran, do we need to give a specific name or
the
anything you
name has
can?
to be Docker file, exactly.
Exactly. Okay.
Yes, it has to be exactly like this. Same name. Okay. Once you create the file, now let's read the file here. 1 second. So what I'm saying is simple. Take the HTTPD image. Okay. Once you take the image, copy this code, copy all the files where on top of the image. That's it. That is what we did also. Okay. Now, but now here, if I say Docker images, there are no images. Okay. And here now, the challenge is how are we going to convert this Docker file into Docker image. Okay. So this is where we will use a command called as Docker build. Okay. Now what is that I want to build? I want to build an image. So what the image? I want to give a name. So I'll say -t tag. What is the image I want to name? So I'll say Cosmic EC app. Okay. The name of my image is Cosmic EC app. And where is the Docker file located? So you can give the path also. If the Docker file is somewhere, no, you can give path also, but it is located in the current directory. So I'll say dot. Okay. Docker build -t Cosmic EC app. So this is the name of the application. Dot represents what? Current folder. That means I'm telling them that my Docker file is in the current folder. Now enter. Now look at this, guys. Now look at this. Okay. What they're saying here, sending build context to Docker daemon. Step 1 from HTTPD. So what did it do? So guys, did we have the HTTPD image first? Did we have the HTTPD image? We deleted, no? Yes, we deleted HTTPD image. Now, what did it do? It downloaded HTTPD image. On top of this HTTPD image, what did it do? It copied the code. Copy code where user local Apache HTTP docs. Which directory? Where did it copy? It copied the code on top of this directory, on top of this image, and then it created a custom image called as Cosmic PC app. So now in this image, what you have is you have a combination of your code. You have a combination of the code and you have the combination of the base image. Got it, guys? Understood? What did you do? You combined your code and you combined your base image. Make sense? Make sense? Yes. Now, if I say Docker PS, I don't have any containers. Docker images. I have Cosmic EC app. Now let's run this image, guys. Let's see what happens. Okay. Let's see what happens. Now I'll say Docker run -dt hyphen name EC -p. Okay. Let's say 8090:80 and directly the name of the image. Directly the name of the image. Now you don't have to mention -v, volumes, path to the volume, nothing, guys, because now everything, whatever you need is on top of this image. Okay. Now I'll hit enter. Now if I say Docker PS, all right, you see, guys, there is a container running. You see this? Now let's browse it. Now let's see, do you think we'll be able to access our application? Let's check it out. Let me close these windows. Let me copy the IP address, paste it here, :8090, enter. Food app. Why am I getting food app? This is ecom, no. Let me refresh once more. Sorry. Yes. Give it another refresh. Indexing is not happening, guys. Just a second. Just a second. Docker images. So I can see image, Docker PS. Okay. So guys, now what we'll do is let's just execute. Let's just go inside this particular container and let's just check out. Let's just go inside the container and let's just check out what is happening. So I'll say Docker execute -it, the container ID. So take the container ID followed by /bin/bash. Okay. Right. Okay. It doesn't have bash, it has sh. There you go. So you're inside the container and here you have htdocs, and inside htdocs you have the code, guys. Got it, right? You have your code. Okay. I'm understanding. So why it is not rendering completely? Because see, this is an Alpine image, guys. The image that we took, no, it is a very lightweight image. It's a very lightweight image. So probably this is the reason it is not able to render properly. So what we'll do is I'll just go to the Docker file. I'll just go to the Docker file. Okay, I'll remove the Alpine image. I'll remove the Alpine version because I don't want lightweight version. I'll remove Alpine version. I'll take the latest version. Okay. And I'll delete the previous code. I'm deleting previous images, Docker RM I'm deleting both images. I'm deleting both images, or I'll let the Alpine be. I'll just delete this normal image. Okay. Docker images. We don't have images. Now again, I'll build, guys. I'll say again Docker build -t. Cosmic EC app, enter. So now it will download the latest image. It will download the latest image. Okay. Now if I say Docker images, it downloaded the latest image. Look at the difference, guys, between Alpine and latest. You have, it's almost 100 gigabytes of difference. Okay. Now I'll run my container again. I'll run my container. All right. Now if I just go back, if I refresh, let me close it. Copy, paste, :8090. Okay, it is still coming out in the HTML format. Okay, I just have to take it back to the developer, guys. I just have to send this back to the developer. Let me just check it out here. Docker execute -it container ID. Docker execute -it container ID /bin/bash. Okay. List cd htdocs list. You have the code, but apart from the code, it is also downloading a lot of different files. Now, where are all these files coming from? Bootstrap, CSS, TXT. Okay. You see, guys, there are a lot of additional files also that are stored here. So probably this is also the reason why my content is not able to render properly. Okay, so what I'll do is once I'll just try an Nginx image. So this is my ecom image, guys. This is my ecom application code. In the code, I went ahead, I created a Docker file. When you build this Docker file, it creates a Docker image. And from this image, once you run this image, you can directly see the application. Okay. Now, similarly, I'll go to the food code, food app, cd food app. Okay. List. So you don't have anything here. Now I'll say vi Docker file, same thing. Now food app, what did we do? So here we use Nginx as a base image, correct? We used Nginx as a base image. Use from command to select the base image. Okay. So now I'll say from, what is the base image? Nginx. Then use copy command to copy the code. So then I'll say copy what? Dot. Oh, okay. Sorry, guys. Sorry. Actually, I mentioned star. Okay. I mentioned star. So when I mentioned star, it will copy all the unnecessary files, hidden files, everything. So now I'm saying dot. Actually, dot means just the files that are in the current folder. Okay. /, where is that I want to copy? I want to copy this to this path. User share Nginx HTML. Copy. Paste. Okay. So I'm saying from Nginx, use Nginx as a base image, copy the code. Now let me save it. Okay. Now I'll say Docker build -t. All right. Cosmic food app dot. Okay. From Nginx. So Nginx is our base image. Now, guys, if I say Docker images, we will see the Cosmic Food app. Okay, you have the Cosmic Food app. Now let's run this. No containers, only one container. Okay, now I'll say Docker run -dt hyphen name. One second, guys. Hyphen name. So I'll say every food app. Okay, followed by -p. I want to run this on 8070, or sorry, 8070 colon 80. And what is the image that I'm using? Cosmic Food app. Enter. It created a container. Let's check it out. Docker ps. My food app container is ready. Let me inspect. Docker execute -it, the container ID /bin/bash. Okay. I'm inside the container. Now, if I go to user share nginx HTML, let's see, is the code copied, guys? Yes, my code is copied. My code is copied. Okay. Now, if I go back, if I copy the IP address, paste it :8070. Able to see my food application running. Okay. Now, again, where is this running? This is running out of my custom image. Okay. And it's running on my own container. Actually, let's also fix the ecom image, guys. Let's also fix the ecom image. So I'll say cd ecom. Okay. vi docker file. Okay. Here I said star, no. So don't mention star, guys. Don't mention star. So when you say star, it will copy all the unnecessary files. Like within files also, it will extract. So imagine when I say star, if there are any folders, it will extract the folders, then it will copy inside the content, the contents inside the folders. Okay. When you say dot, it will just copy the content as it is. Folder wise, file wise. Okay. I'll save it. I'm removing the EC container. Okay, EC container is gone. Docker images. I'll also remove this image. Docker RMI EC app. So I'll delete this image. Now I'll build a new image. Docker build -t. Got it? And Docker build -t. Followed by Cosmic EC app dot. Enter. From HTTP image, it copied the code. Okay. Docker images. Now we have a new image. We have a new Cosmic EC app. Now let's run this. Docker run -dt -name. What is the name? I'll say EC -p 8090 colon 80 Cosmic EC. So I have a new container. Now let's browse it. Now let's go back. Same 8090. I'll refresh. There you go. So we have our application running, guys. Yes. Is our application running? Yes. But it is running on top of where? It is running on top of, am I using some more containers to run my application, or am I directly running it as a customized container, guys? Here. Now, if I say Docker images, I have my custom image, e-commerce image, food app image. Okay. And then when I run this image, it is going to go ahead. It is going to create a container. When I run this image, okay, it's going to go ahead. It is going to build your custom container. So this is the beauty of Docker, guys. This is what you need to know. So first you need to know how to build and deploy the code manually. But later, now you need to understand how can you go ahead, how can you build the code, and how can you deploy this code and convert this code in form of an image. Later, run your application through this image. Got it, guys? How to build an e-commerce code, image, how to build food application code image using HTTP as a web server, Nginx as a web server. Got it? Clear? Any questions still here?
So we have taken a, customized file, and through that file we are accessing this service, right?
That's right. So already there are some images, okay,
Yeah.
servers. You took this customized image. On top of this customized image, you copied the code, you created your own image.
Yes.
And now you run the image, you are able to see the application.
Okay.
Got it, guys? So guys, in production, our job is once you get the code right, once you get the code, no, first, depending upon what programming language it is from, if it is from Java, Python, JavaScript, depending on what it is, or if it is just a static code, you will build the code. Later, you will convert the code into an image. Later, you will convert the code into an image. Then you will take this image and run this image from Kubernetes. That is later. That is later. But before I proceed further, just let me know, is this clear? How to build Docker images, static images. This is static images. How to build static Docker images. Is it clear? Clear? Any questions here?
Kiran, do we follow this process on live? I mean, live environment?
Yes, of course, Jagdish. This is the primary job.
Okay. So if there is any possibility, I mean, is there any chance that containers break?
Containers break? Yes, containers will break.
Okay. If it fails, for
Hmm.
example,
Hmm.
so do we need to run the container once again, or it will be automatically create containers?
Very good question. Very good
It
question.
will be
Oh,
in. It will be handled by I think this Kubernetes, right?
that's
I
right. Very good. See, now Jagdish, in the position that we are in, Docker can only help you to build images, deploy images in a standard old fashion. Okay? Docker is not going to give you auto scaling mechanism for your containers. Got it?
Okay. Okay.
No, you want auto scaling, fault tolerance mechanism for containers and servers. Then you want Kubernetes. We will see that in tomorrow's class. Got it?
Okay.
Yeah. So first, is it clear? Can I proceed further with the next topic on this? Yeah.
Yes.
Okay.
Kiran, also one more question.
Yes, yes.
So, we have the source in our VM, right?
Hmm.
So, if we made any changes on the VM, it will
Hmm.
be automatically reflect on the container side also.
No. Again, you have to build the image.
Okay.
See,
So, mm,
see, what is the flow? You guys remember the flow, right?
mm,
Developer will write the code, tester will test the code. You know the flow, right?
yes,
SDLC flow. You guys remember SDLC flow?
yeah.
Yeah, developer will, okay, or 1 second, what I'll do is, let me open this one.
I think this is the exact work for the. DevOps engineer, I guess.
This
Every
is your
day
primary
checking,
job.
and yeah, every day we have to check and we have to create image.
You'll not check, Baba. You will automate it. See, every day nobody will wait for you to come to office and check. No,
Okay.
got it right? You have to automate this process. So how this automation looks, I will just tell you. Hmm. Ah. See, this is the flow, guys. See, what are we doing? First, what did we do? Did we clone the code? Yes. We tested the code. Yes. We built the code. After that, we released it, we deployed it. This is what we did, right? Yes.
Yeah.
Yeah. This is manually. This is what deployment? Manual deployment. Now, what we are doing is after you build the code, no? After you build the code, oh, come on, man. After you build the code, you will have a build version. So there is an artifact that you are generating. There is a final version of the code that you guys are going at, that you guys are generating. So where are you storing this final version of the code? Where are you storing this final version of the code? On the repository manager, build repository. Now, then from there, what you're doing is you'll take this final version of the code, you will convert it into a Docker image. Got it? So the primary job is to build, release, convert this into an image, then run this image through Kubernetes. So now this is the most important stage, guys. You know how to build, you know how to deploy manually, but now you need to containerize your application. Now, why? Now I will tell you why it is very important. Okay. So here, see, guys, we are building static code, DevOps code, ecom, sorry, food app, ecom. This is static application. Now, let's say I want to build a dynamic code. So what is this dynamic code? Let's say I want to build a Java application code. So I'll just go to GitHub and I'll just get a Java code, Java calculator. So let's get this Java web calculator. Okay. So this is Java code. Now I'll copy the code link. Okay. I'll copy the code link. Git clone. Let's clone the code. Now, for this code, what you're supposed to do, guys, you're supposed to build it first. Yes. So what are the components I need to build? I need Java. Do I have Java? I don't have Java. So I'll install Java. Okay. Now, if I say Java hyphen version, okay, Java hyphen version, I have the Java version 1.8 and I also need Maven. I don't have Maven, so I will install Maven. Okay. So Maven is installed. Maven is installed. Now, if I say Maven package, what will happen, guys? Maven will go ahead, it will build the code, it will give me an artifact. You know this, right?
Yes.
Okay. Build failure. Why? Compilation failure. Perhaps you are running on a JRE rather than JDK. Okay. 1 second. Install Java 8. So app get update. So let me just update the machine. All right. Now install JDK. You need to install JDK. So I'm going ahead, I'm installing JDK.
Kiran, all these installations required even we are using the Docker or
Yes. See, for build, you have to follow the same process.
okay.
See, till you convert the code, you have to follow this process.
Okay.
Got it, right? Now I'll tell you where it comes into the picture now. Okay, now if I say Maven clean, let me clean and install again. Okay. Now if I say Maven package,
And can't we do that with the Docker, like Docker file?
sorry, can you repeat it?
Nothing.
All right. So pay attention, guys. Here, build is successful. Build is successful. Output. Your output is in the target folder. Yes. This is the output. Now to deploy this, what you need, guys? To deploy this, what you need? You need Tomcat. Correct? You know this, no? What did we do in the last class? We installed Tomcat manually, we configured Tomcat, we have configured Tomcat bin directory, then we copied the code. But now instead of using Tomcat server, now I will use Tomcat image. First, we will see what is the difference. Okay? Okay. Okay. Now, Tomcat. So now, guys, I will just run this Tomcat image. I will just go ahead. I'll just run this Tomcat image. First, we will see, are we going to get the exact output? Okay. Just Tomcat CD. So here, Docker images. We don't have Tomcat image. I'll say Docker run -dt -name tc test Tomcat test -p. Tomcat runs on 8090. No, I'll run it on 9090 : Tomcat runs on what port, guys? Internally, it runs on what port? 8080. Very good. So this you have to mention. Okay. This is internal. This is external. Okay. And what is the name of the image? Tomcat. Got it? Enter. Unable to find Tomcat locally, it is pulling from the library. So it is going ahead, it is downloading the image from the library, and then it will run the container. Once the Tomcat container is running, no, we will analyze the container. We will see how this Tomcat server is different from the other server that we were running. So now if I say Docker PS, all right, we have the Tomcat container. It is running on port 9090. Okay. So if I go back, copy IP address, paste it, :9090. Okay. Enter. All right. Okay. So forget about this error, guys. Forget about this error. But do you see this? What is it saying? What is the version of the Tomcat, Apache Tomcat? What version? 11.05. Latest version. But you might be saying that, hey, Kiran, there is a mistake. So this is not the output that we want, right? Am I correct? This is not the output that you want. So what you have to do is, once your container is running, guys, you just need to modify some things in the container. Okay. So I'll say Docker execute -it, go to the container ID /bin/bash. Now in this, so I'll tell you, okay, there is some configurations that you have to manage. So this output that you're seeing, right? Where is this output coming from? Yes, where is this output coming from, guys? Web apps. Got it? This output is coming from web apps. And in web apps, you don't have, everything is empty. That is why you are getting this output. So now what you have to do is just go back, okay? So similarly to web apps, there is another folder called as webapps.dist. So if I say list webapps.dist, in this, you have some configuration folders, okay? You have to copy these files to this folder. How to copy? Copy -r webapps.dist star, okay, star to which directory? To webapps directory, okay? Enter. Now, is it copied? Is the content copied? Content is copied. Now, if I go back, if I refresh, can you see the landing page? Yes.
Yes.
Now, in the landing page, what is my concern? This is my concern, no? Manager app. Yes. If I click on manager app, same thing, guys. Again, you can also configure. Here also, you can modify context.xml, add username, role. You can do this, but we are not going to do this. So today, how we are going to work as is, first I'll just go back. So I'm inside the container. I modified a configuration, but if I exit the container, guys, this configuration, okay, where is this? This configuration is only available in this container. If I lose the container, again, I have to update the configuration, correct? If I lose the container, again, I have to update the configuration. So what you can do is, you can build your own custom Tomcat image as one option, or when you are building a Docker file, no? So for now, imagine I want to use Tomcat I want to use Tomcat. I want to build a Docker image. So I'll go to the Java calculator first. You have the target file here. Okay. So here I'll say vi Docker file. Okay. Here now I'll say use Tomcat as base image. So I'll say from Tomcat. Now after this, what I have to do is update configuration on Tomcat image. So what should I do? So inside I ran a command, no, copy something, copy -r. Okay. So here I have to say run. Okay. Now where this run command will come is when you want to run any commands inside a container, then this will come. So I'll say run copy -r webapps dot dist /star. So I'm saying the contents in this folder should be copied to which folder? Should be copied to the web apps folder. This is what we did, no? I went to the Tomcat server, I updated configuration. Yes, guys, this is what we did. Yes, no, maybe so. Correct?
Yes.
Now, after this is done, what I want to do is copy artifact to the Tomcat server. Very simple. So how do I do it? Copy. Okay. Copy what? In the target folder. Okay. In the current directory, or I'll simply say in the target folder, there is a star.var file. Okay. There is a var file. And where is this I want to copy? I want to copy this to this path, to the web apps path. So what I have to do is I have to give the complete path, guys. I have to mention the complete path. Tomcat document root directory. Here you will have the path. User local Tomcat. User local Tomcat. 1 second. User local Tomcat web apps. Okay. So this is a base image. So here, user local Tomcat / web apps. Okay. Now I'm saying take a Tomcat image, modify the configuration, copy the content from my target directory, copy the content from my target folder. Inside the target folder, you have the folder called as star.var, and copy this var file to this artifact. Okay. Now I'll just save this. Now I'll build an image. So I'll say Docker build -t Java app dot. Let's see what happens. There you go, guys. It executed very smoothly. From Tomcat, it took the base image, it updated configuration, it copied the artifact. So let's see. Docker images. We have the Java app image. Now let's run this. Docker run -dt -name Java -p. Let's say I want to run this on 9080:8080. Image name Java app. Enter. My container is ready. Let's execute the container. Docker ps. Docker execute. First, let's check if everything is fine. If everything is placed currently in the container, let's check. Docker execute -it container ID /bin/bash. Enter. Now, where are you? This is the path. User local Tomcat. On top of this path, where did we copy the artifact? Yes, where did we copy the artifact, guys? Web apps.
Web apps.
So if I say cd web apps, let's check it out. List. Do you have your artifact, team? Yes. Do we have the artifact?
Yes.
Yeah. Now let's browse it. Now we don't want this. Now, okay, I'll just take this link. Okay. What is the port?
8090.
9080, I guess. 9080. Enter. So 9080 is taking you to the landing page. Okay. Now I'll say slash. What is the artifact name? Web app hyphen 0.2. Web app hyphen 0.2. Enter. Is my application running, guys? Can you see the output? Yes.
Yes.
Now I deployed an e-commerce application, food application, Java application. But how did I do this? How did I do this, guys? I did everything on a single server. I did everything on a single server. So here we went ahead, we created our own custom Docker images. So these are our images. And now these images are running without any dependencies. For suppose here, do I have Nginx installed on the server? No. Do I have HTTPD installed on the server? Do I have Tomcat installed on the server? No. So without installing, I'm still running application. So what am I doing? If I install these components, my server is getting heavy. My server is getting heavy. This is the first thing. Now, second thing, now I'll tell you one more thing, the most important concept. Now, I'll just go to another server, guys. So I'll just take another server. Okay, I have something called as Node app. No, I'll just take this server. Or I'll take Node lab. I'll take this server. I'll start it up. Because I don't have anything running on this server. Okay, I'll just start it up. Okay, it's running. So let me connect to this server. Let me connect. Yes. So guys, this is a brand new server, right? So if I say Docker, Docker is not installed. So let me install Docker. Docker is installed. All right, perfect. Now if I say Docker images, I should modify permission sudo chmod 666. Copy. Now if I say Docker images, can you see the images? Any images? No images. Docker PS, no containers. Now, if I try to run this image here, guys, let's see what happens. If I say Docker PS, now I want to run this image, sorry, Docker images. Now let's say I want to run this image, Cosmic ECR, okay? So here if I say Docker run -dt hyphen name EC -p 8090:80. What is the name of the image? Cosmic EC app, correct? Now if I hit enter, now see guys, what is it saying, guys? What is it saying? What is the error? Can you see the error? Full access denied for Cosmic EC app. Repository does not exist. What are they saying, guys? They're saying this image does not exist. Now tell me, why are they saying this? Why are they saying this image does not exist? Enduku.
That image only we are created in our VM and it is not pushed into the Docker.
Very good. Very good. Very good. Very good. See, guys, this images are created on which server? On Docker Lab server. So, guys, see, if the container is gone, no. If the container is gone, one second. If the container is gone, I can create a new image. Sorry, I can create a new container with the image. But imagine now if this server is itself gone. Now what if this Docker lab, if the server is gone? So again, what you have to do? Again, same headache. Again, you have to clone the code, build the code, take the image, build your images. Now to avoid this, no, what you will do is in production, what we do is once your images are ready, guys, okay, once your images are ready, now you should have a Docker Hub account. So here you should have a Docker Hub account. So just go to Docker Hub. I already told you to create a Docker Hub account. Okay. Docker Hub. All right. Okay. I already logged in here. I log out. So this is your Docker Hub, guys. So on the Hub, there are already images. You know that, right? On the Hub, you already have images. We know that. Guys, just a second. Let me connect charging. Yeah. So on the Hub, you already have images. But if I search for Cosmic EC app, there is no image like this. There is no image. Okay. Now what you need to do is whatever the image that you created on local machine, you need to update this image to Docker Hub. You need to update this image to Docker Hub. So how can you update the image? Very simple. So first, you have to log in into Docker, guys. Okay, log in into Docker, sign in. That's my email address. And I'll give a password. That's my password. So you need to log in into your Docker account. And once you log in into your Docker account has something called as repositories. Your Docker Hub has something called as repository. Just like in GitHub, what is the repository, guys? What is the repository in GitHub? Yes.
Code storage.
So very good. So in GitHub, you see, in GitHub, you also have repositories. You also have repositories. Okay. You also have repositories. If I open the particular repository, I can see what is this repository is about. I can see what is this repository about and who's the owner of the repository. This is my owner name. This is my repository name. Correct? Same thing, even on Docker, you have repository, but this repository is about images. So here you have to update the images with your username. So first, now what you have to do, guys, after your image is ready, so these are the images now. So you just have to attach your username to the image. You have to tag your username to the image. So how to tag? Let me tell you. So I'll say Docker image tag. Okay. What is the image name? Cosmic-EC-app. What is the tag I want to give? Akiran Reddy / Cosmic-EC-app. Got it? Enter. Now, if I say Docker images, you see, guys, there is a new image. Akiran Reddy, Cosmic EC app. So what did I do? Older image only. I just attached a name. Or you guys, what you guys can do is when you're running the command, no, Docker build. When you're running this command, no, Docker build image. Here also directly you can give the name. Here also directly you guys can give a username. With the username, you guys can go ahead, you guys can mention the image name. Okay. So now I have my custom image, Docker images. I have an image with my username. You see, Akiran Reddy is my username matching Akiran Reddy. Now what you're supposed to do is now you will simply say Docker push this image name. Just copy this image, paste. That's it. Okay. Enter. Now you see, guys. Request access to the resources denied. So now I want to push. See, you have to push into somebody's private repository. This is my repository. No. So even if you make a change with the name, let's say you give the name Akiran Reddy, even if you try to push, it should not work. So why? That is where there is a security layer. So before you push, what you do is we run the command called as Docker login. Okay, Docker login, enter. It's asking for username. So my username is Akiran Reddy. Password. So whatever the system password that you have, you guys can give it. Login succeeded. Now it knows my username and password. Okay. Now if I say Docker push, let's see. Pushing the images. Push complete. Pushed. Okay. Now if I go back, if I refresh, do you see our latest image, guys? Do you see the latest image? Akiran Red, Cosmic
Yes.
ECR. So I just pushed one image. Let's push all. Let's push all the other images also. Docker images. So first let's tag them. Let's tag them. Docker image tag. Now I'll say Cosmic Food App. Cosmic Food App with Akiran Reddy Cosmic Food App. Okay. And then I'll say Docker image tag. I'll say Java app. Java app. I will say Cosmic Java app. The name is Cosmic Java app. Enter. Now we have two images. Okay, look at this. Akiran Reddy Java app, Akiran Reddy EC app, Akiran Reddy food app. So in production, what you do is you tag this with your organization name. Your organization will also have a Docker Hub account. You will use the name of the organization Docker Hub account. Okay. Now, second. Docker images. Now, if I say Docker push, what is the name of the image? Java app. I'm pushing Java app first. Let it go. Now, again, Docker PS, sorry, Docker images. Docker push. What is app? Food app. Copy paste. Food app is also getting pushed. Perfect. Now, if I go to the Docker Hub, do we have all the images here? Do we have all the images updated here? You have food app, Java app, EC app. Now, guys, now what we'll do is now we'll delete the server. Okay? We'll delete the server. Now imagine the server is gone. Let it go. No problem. No problem. Now you're on a new server. You're on a new server. This is the new server. Yes. So here, if I say Docker run -dd Cosmic app, what did it say? There is no Cosmic app. But now on this new server, again, I will say Docker run -dt -name EC -p 8080:80. Now the name of the image, but what is the name of the image, guys? What is the name of the image? Akiran Red Cosmic EC app. Yes. Slash Cosmic EC app. Got it? Now I'll hit enter. You see, it is pulling the image. How does it know? Because it is updated on the Docker Hub and this is public image. Public. You guys can change it from public to private. You guys can change it. Public image. Docker images. it pulled the Akiran Red image, Docker PS, it created a container. Now, if I go back, if I copy the IP address, colon, what is the port? 8080, sorry, 8080, enter. Ecom is running. Same, food app also. Akiran Red, Cosmic Food App. Same thing. Docker run -dt. I'll say food app, FD. Port, I'll say 8090. Image, Akiran Red, Cosmic Food App. Enter. Building the image. Docker PS 8090. So if I go back, copy IP address, colon 8090. You have the food app running. Same thing with Java app also. Same, Docker run -dt. We'll just say Java Akiran Red. What is the name of the image? Cosmic Java app. Cosmic Java app. Port, we will just say 9090. It is going ahead, it is downloading the Java app image. Docker images. It downloaded Java app image, Docker PS. You have the container here. Okay, it's running on 9090. Now, if I copy the IP address, colon 9090 slash web app -0.2. Enter. One second, guys. What's wrong? One second, guys. Docker run -dt -name Java app -p 8070 colon 8080. Oh, sorry, guys. See, internally it runs on 8080, no? I said 80. This is a problem. Colon 8070 8080. Name of the image. Enter. Right now, if I say 8070, my application is running. So now look at this, guys. On a brand new server, did we download the code? Do you see the code anywhere? Code is not there. Do you have HTTP? No. Do you have Nginx? No. Do you have Tomcat? No, nothing. No dependencies. But without any dependencies, I'm able to go ahead. I'm able to build and deploy my images, or I'm able to build and deploy my applications through Docker. So this is the power of Docker, guys. Once your application code is ready, once a developer gives you the code, you are going to go ahead, you are going to take this code, you are going to build the code. If necessary, you will store it on the binary repository artifact, or the build version, you can directly convert it into an image, then store this image on top of your Docker Hub. Once the image is stored on the Docker Hub, from here, Kubernetes will come into the picture. Got it? From here, Kubernetes will come into the picture. Clear, guys? How Docker works. How Docker works. So this is the most in-depth. Somebody can tell you how exactly Docker works. Clear, or any questions still here? Everybody, clear?
Yes.
Got it? Yes, guys, got it? So now,
Yeah, Kiran.
okay, now see, whichever code you might be working on, Java code, JavaScript, Python, or .NET, any code, your responsibility is first to make sure that the code, the artifact is deployed properly. That means first you have to make sure manually, you should deploy it manually, check if it is working properly, then convert it into an image, store this image on top of Docker Hub, store the image on top of Docker Hub. From here, Kubernetes will come into the picture. Got it, guys? So in tomorrow's class, I will tell you, see, now the problem is, if container crashes, so guys, okay, if the container crashes, is there a problem? Is there a problem if the container crashes?
No,
Why?
because we have images already.
Very good. Very good. Because you have the images already. Now all the containers gone. Do I have a problem? No problem. Because I have the images already. I can create new content. But now if the server itself is gone, imagine server is gone, then what will you do? Again, you have to create new server, install Docker, run all the images. So rather than that, now to manage auto scaling on server level, to manage auto scaling on containers level, we will use something called as Kubernetes. Got it, guys? Kubernetes is the most in-demand important tool in today's environment. So what Kubernetes does, Kubernetes helps you in order to go ahead, in order to run your containers in a continuous integration and a continuous delivery manner. If the containers crash, Kubernetes will take care of it. Got it, team? Make sense? Make sense? Any questions? Any questions?
We are using Kubernetes for the instances, I mean to say VMs crashes, so it will be automatically create new
VMs
VMs.
will be automatically created. Containers will also be automatically created.
Okay, but for example, if we have the food application, right?
Hmm.
So if we make any changes on the food applications, like we are adding any new feature,
Hmm.
so does it also automatically updated in the
So, okay, very good. So when there is a new feature, when the developer adds a new feature, same thing. You will test it, you will build it, you will convert it into image. Okay. Once you convert it into image, and this image is updated on Docker Hub, and what happens is there is something called as Argo CD. So what this Argo CD does is it will check if there are any latest versions. If there is a latest version, it will pull it, it will deploy the latest version.
okay, we need to learn it in future.
Yes, yes, of course. You have to manage everything, guys.
Mhm.
Right. You have to manage everything manually. Later,
Is
you
this
will
the
connect all these dots and automate it.
is this the I mean separate service or it includes in Kubernetes?
Argo is a service that is part of Kubernetes.
Okay.
Got it?
Okay, as of now, we are working only on Docker. Everything apart from that, everything are managing on manually. So we are going to automate it in with the help of Kubernetes, like
That's
code
right.
updates and VM crashes, load balancing, all the stuff.
Everything. Whatever I taught you in Azure, no? Distribution of traffic. All right. So everything has to be, everything will be handled with Kubernetes.
Okay, so we are in the initial stage. So we are going to deep dive into it, right?
Kubernetes, yes, of course. See, in Docker, we spent good 3 classes, right? Yeah. So you guys, when we started, you guys had no idea about Docker. Now you know everything about Docker. Yes or no? Yes. Volumes, containers, images, tags, execution, inspection, porting, persistent volumes, Docker file creation. Now you know everything. Same thing. Kubernetes also, we will deep dive. We will learn all the services in Kubernetes. Got it?
Yeah.
Yeah. Okay. So before that, there is one small tool I just want to talk, guys, that is called as Trivy. So what is Trivy? Trivy is the latest addition in today's technology. Okay. So Trivy, what is Trivy? So Trivy is a comprehensive open source security scanner developed by Aqua Security that identifies vulnerabilities and misconfigurations across various resources, including container images. Got it? So now you need a tool to test if there is anything wrong with the image. So now guys, see, with the help of Docker, I created image. Okay. Now we have images. But now I just want to test if this image is fine or not. Then you need something called as Trivy. So we'll just install Trivy. Working with Trivy is very easy. Trivy. And all I have to do is, I just have to say Trivy followed by the name of the image. Trivy followed by the name of the image. Enter. And what Trivy will do is, it will check, okay, it will go ahead. Once again. Sorry, Trivy image. Trivy image. The name of the image. Enter. You see, guys, it is going ahead. It is again validating the entire image. It is checking. Okay, it says need to update database. Who has to update? On the Tomcat's end. So this is not something that you're going to do. Update database on the Tomcat's end. Okay, so like this, you will find lot of inputs, and whenever there is a serious input, no, Trivy will say critical. Okay, you will get some errors like critical or fatal. Let me show you if we get anything. So it will scan the image layer by layer, guys. Every layer it will go ahead, it will scan the image. First, it says need to update DB. So the Tomcat image, whatever we are using, no, on the Tomcat image, there is a DB that is configured. It will go ahead, it will update. Fatal. Now look at this, there is an error. Image scan error, scan failed analysis, analyzing error. What is this? We have an error, guys. Pipeline error, unable to initialize the Java DB. The Java DB update failed. DB download error, OCI error. So here, what is it saying is, there is a problem with the Java DB. So currently we are not facing any problems, but in the future you might face problems where this image needs to be updated, guys. So it says need to update DB. But did we use any DB? No. But when you're using the Tomcat image, the Tomcat image has a default database configuration in the backend. So like this, you will get errors. And now let's see one more image. Trivy image. Let's look at EC image. For this, there is no database errors. Okay. Now look at this. It is scanning the complete image. It is scanning the complete image. Scroll up. And it is checking layer by layer, guys, layer by layer. So again, guys, if you want to understand what is all this components, medium, high, what is all of this, you can go to the official Trivy website, check it out. But this is not our concern. So you guys can see the quality parameters, medium. And where is it coming from? It is coming from the library. So it is going ahead. It is analyzing the library documents. Okay. It is analyzing library documents, apt bash. You see, it is performing. It is checking the repository. It is checking the shell. It is checking the utilities. Okay. It is checking the compiler, libraries towards the left. You see what all it is scanning? It is scanning libraries. Scroll down, mount points, OpenSSL password. So if you see, it is going ahead, it is checking each and every single folder or each and single executable file. And finally, here you see there is a critical output. It says critical. Okay. Now this might be an issue. So critical. So where is the problem? Integer overflow and resultant head-based buffer overflow in Zypper. Okay. Now I can just copy this. Go to the browser. I can say Trivy error. All right. So you have the output. you guys can analyze what is happening. Okay, what is happening? What is it going through? But here, guys, here, the primary purpose of Trivy, is to check if the images that we are using in our build management, are these images are up to the latest version, and are these images up to the best version, and are these images compatible? For suppose when we scanned Tomcat, no, here this image is not compatible, guys. That it directly threw me an error. It simply said fatal because buddy, Java database is not updated properly. So I have to go ahead, I have to take a different image. If there are no errors, I can just proceed further with this. Same thing here also. So currently, after analyzing everything, if you see the number of errors, everything is low to medium. Everything is low to medium. Only one thing is critical. Only one component is critical. I can either let it be, so this is fine, or I need to go ahead, I need to take a build and I need to take another image like HTTPD or Nginx base image, check for the latest version, check for the updated version, deploy your image on top of this updated version. This is exactly how Trivy works. So what Trivy does is, once you build an image, Trivy will check if there are any changes that needs to be made in this image, if there are any flaws in this image, if there are any updates that are required on top of this image. That is where Trivy.
So ultimately checks for the latest versions of the installations and all, right?
Yes, yes. So what you have to do,
Okay.
what we have to do,
It scans and yeah.
when we are building a image, right? Yeah. Base image, you're taking base image, no? Nginx or whatever base image you'll take, no?
Yes.
You have to take the updated version, the latest version, and the updated version. Got it? So
Got
these
it.
are all the things that you have to remember when you guys are working on Docker, guys. So now Docker, now you understand what is Docker. It's a containerization it's a containerization service where we previously understood how we used to deploy applications on virtual machines, on virtual machines. Now we are deploying applications where, guys, on top of what? On top of containers. And how these containers are created with a tool called as Docker. Clear? What is Docker? What is Docker? Where is Docker coming into the picture? How Docker is helping us to minimize the size of the application and run multiple applications or services on a single server. Clear? Any questions here? Everybody understanding?
Yes, sir.
Yes.
Guys, see, this is the final phase. Okay? Whatever you did on Azure, no, you can park it aside. When I say park it aside, don't forget. But whatever you did on Azure, so that is just the foundations, guys. But this is the core technology. Tomorrow, if you're giving an interview for a DevOps engineer, DevSecOps engineer, nobody will ask you about infrastructure unless and until it has some cloud involved in it. So whatever I taught you on cloud, that is just a foundation, but this is the core technology. You should master this technologies. Whatever I'm teaching, just spend time on this, follow the notes, just follow whatever I have to tell you. After this, I'm also preparing interview deck. So if you've seen, I'm preparing topic-wise interview deck. You saw this? Did anybody see this? Yes. So just follow this, guys. Follow this, and I bet you, I guarantee you, any job role that you come across who are looking for an experience between 3 to 5 years, you guys will be able to crack it. Got it? Yes. Clear?
Yes.
Okay. So in tomorrow's class, now we are going to go ahead. We are going to get started with Kubernetes. Yeah. So you'll understand what is Kubernetes, where Kubernetes is coming into the picture. What is orchestration? Kubernetes is an orchestration service. What is orchestration? Why do you need orchestration in our environment, and where you guys can introduce Kubernetes? Good to go?
Yes.
All right. That's it, guys. That's it from my end. See you guys tomorrow. Yeah. Bye, guys. Take care.
Thank you.
Thank you. Thank you, guys. Bye, guys.